This is the RubyMotion talk. If you had any questions on what this talk was about, it's about Ruby in your pocket. If it's an iPad, it probably won't fit in your pocket, but it is about Ruby in your pocket. I am not Laurent Sansonetti, who was going to originally give this talk. Laurent is the creator of RubyMotion. Unfortunately, due to flights not going through New York, was not able to get here. I am Rich Kilmer. I've been to every RubyConf, and I've been to every RailsConf. That just demonstrates how little life I've had for a very long time. I was the founder of InfoEther, and the CEO of that company was acquired by Living Social about 18 months ago, and I've been at Living Social ever since. And I'm actually an advisor to HipByte. HipByte is the producer of RubyMotion. Laurent works for HipByte. And I am wearing white pants today. So this is a website that says, is Rich Kilmer wearing white pants? I did not make this website, but it does track whether I'm wearing white pants or not. And today I am, just so you know. And if you're really bored, right, you can go look there. So this talk is about RubyMotion. And RubyMotion, the question is why to write this? Why was it important to write Ruby and use the Ruby language to run on an iOS device? Well, probably the most important thing is numbers. There's 400 million iOS devices out there right now. There's 435 million iTunes accounts with credit cards behind them right now. Actually, that was in June, so there's more than that now. That is a staggeringly large number of devices out there and of accounts for making things. So one of the reasons to do this was because it's a very, very large ecosystem out there. A large number of devices exist that this can be used on. And, but the question is, can you use this to build apps that actually run within this environment, within the store? The first app ever written in RubyMotion that was actually put on the App Store was called Everclip. This lets you actually get clips and send them up to Evernote. It was built completely in RubyMotion. It was compiled down and actually uploaded into the App Store. It makes use of third-party Objective-C libraries. So this app makes use of third-party libraries. It won the Evernote DevCup Award. It was accepted into the App Store, and it's for sale there. So applications can actually make money written in RubyMotion. So this is another reason to actually do it. This talk is basically going to cover these items. Explain what RubyMotion is, how it works, what the tool chain is for it, that you can continue to use your favorite editor when building RubyMotion projects, and what the community looks like. First off, RubyMotion is a complete implementation of Ruby 1.9. It's statically compiled, so it's not an interpreter that runs inside your phone. You take your Ruby code, it statically compiles it down to machine code. We'll talk about that. And then it runs within your phone as any Objective-C application would run inside your phone. There is no eval. So it's Ruby minus eval. But all the other dynamic aspects of Ruby you can do. You can do define method. You can pass blocks to define method and actually still do all the dynamic things. You can override what methods do on numbers at runtime and do stuff like that. Let's change what add plus does on an integer. You can do that sort of thing. The same kind of wonderful things that we can do with Ruby, we can do here. So that the dynamism of Ruby is maintained, but eval is not there. Specifically because Apple doesn't let you ship an interpreter, or I should say a compiler, inside your app on the phone, right? So these are compiled using your Mac, and then it's compiled down and actually targeted to your phone. This actually is interacting with Apple's tools. So the tool chain is actually leveraging Apple's tools underneath to compile and produce this. So let's talk a little bit about the runtime. This runtime, the RubyMotion runtime, is exactly the Objective-C runtime. There is no other runtime. When you take an Objective-C source file and you compile it, that compiles down to code that runs on the Objective-C runtime, which is built on the foundation framework in the iOS SDK. RubyMotion compiles your Ruby code down to work on the exact same runtime. It's a unified runtime. There's been other products out there that have used a bridge technique to take one runtime, say a JavaScript runtime, and let you develop iOS applications in JavaScript that are native, right? But those techniques are basically having two runtimes running at the same time. And they're bridging between the two runtimes. Objects exist on both sides of that bridge, and you have to maintain them. The problem there is that it takes more resources to do that. It's not going to be as fast. Whatever they've implemented across the bridge is what you can do, right? If they haven't implemented or exposed something across that bridge, you can't actually get to it. So because we're sitting on the same runtime, you can do everything that you can do with Objective-C in RubyMotion. There is a small Ruby layer, and I say small, it's less than a meg, that adds behaviors to the objects to give you, for example, the behaviors we expect in string and kernel. Those things need to exist because that's our Ruby code, right? We want kernel. We want modules. Modules don't exist in the Objective-C runtime. So there is this layer. It's not a layer. It is an additional capability which is brought into the Objective-C runtime and is run there to allow your Ruby code to run and to feel like Ruby code when you're looking at your inheritance hierarchy. You see kernel there just as you always would. And so that layer is there, but it's not a runtime in that sense. There is no bridge. So one of the most important aspects of this is one of the reasons we love Ruby. Ruby is a very concise language. How many people started programming writing C code? Started writing C code. How many people then moved on to Java code? Right? Lots of Java code, right? Java is one of those languages in C and a lot of these languages. And realize Objective-C is C with objects. It was a branch of C that went off in one direction when C++ kind of went off in another direction. And it added objects, almost a Smalltalk-like object structure to C. But Objective-C is C. When you loop in Objective-C, it's a C loop, right? So Objective-C is C plus objects. Ruby is a purely object-oriented language. When you loop in Ruby, you can use iterators, you can use everything that you're used to in Ruby. It's a very nice, high-level, very concise language. This is hello world in Ruby that, when compiled down in RubyMotion, would actually implement a class that initializes with what you want to say, and when you said to say that, it would say hello. This is a comparable class in Objective-C. You've got a header file here that declares it. You create a class, an implementation of it. You implement a method that says hello. So if you look at that, it ends up that Objective-C is roughly 3 times the amount of code that a comparable RubyMotion file would be. So it's about 3x. Or 1/3 the lines of code basically can go away just from a line count. Now, that doesn't mean that you're not dealing with the same frameworks. You're dealing with the same frameworks that Objective-C is. It's the same frameworks that are on the phone, on your iPad. It's the same thing. As a matter of fact, you can code, I'm sorry if you can't see this from the back, but you can code here. This is actually talking to OpenGL. You can code directly to the C libraries. So this is Ruby code calling C libraries, including constants. So all the constants available in C are available in Ruby as constants. All the functions available in C are available to Ruby, and you can call them. This is 100% of the Objective-C and C API are brought up into Ruby to be able to do this. So let's talk a little bit about how this actually happens and the compiler. The compiler is based on LLVM. So the technology used here is the LLVM technology to compile it down, the Ruby code down to native code. And it's compiled ahead of time. It's compiled on your desktop computer to target the phone or to target the simulator that runs within your computer. And it's compiled down to a single executable. You don't load things dynamically at runtime like you do with Ruby, like we have shared libraries and various things like that. We don't do that here. It's all statically compiled down to an app, an IPA file that actually is loaded onto your device and run. So you start with your Ruby code, and it produces machine code. And the steps for that, the first step is we've got our Ruby source code. So we've got our class here, hello view, subclass is UI view. So if anyone, by the way, how many people here have done iOS development? Yeah. How many people, and it's fine if you do, but love Objective-C as a language, right? So it's cool. No, I mean, it's fine. I mean, there's nothing wrong with loving it because it's a tool that you have, right? And what sucks is having to work in a tool that you don't love. Now, how many people here love Ruby? Right. See, that's the thing. So, right, compilation steps. So we write in this beautiful language that we've grown to love. The first step is to parse this into an abstract syntax tree. So this is the syntax tree that's parsed into. This is similar to what Ruby does internally. When Ruby's parser runs in your code on your desktop computer, it forms an AST. The next thing it does, though, is it compiles it down into what's called the LLVM intermediate language. It's this internal language that's basically a portable assembly language that LLVM has developed, that project. And it's a place where you can actually apply optimizations to the code. So at this step, there's all kinds of optimizations. And by the way, the LLVM team has created a whole series of optimizations. Reorganizing code, removing dead code that you don't reach, right? It can do a lot of those things. HipByte has actually created a whole series of optimizations for the Ruby language itself as part of this compilation process. Things like instant variable access speed increases. So accessing instant variables instead of just looking them up in a hash or something like that. How do you do that incredibly fast? Because we access instance variables in our classes all the time. So how do you do that? And how do you achieve dynamism without sacrificing speed? So how do you cache that? How do you cache methods that you're calling and things like that, even though that method could be a different method in the future because you wrote define method and it replaced the method. So a lot of those optimizations are built in as part of the compilation step. And then it goes down to assembly language. So at this point, the assembly language produced here is very similar to what you're, ultimately the assembly language is machine language, but it's brought down exactly like the Objective-C compiler has compiled your Objective-C code, your C code, down through the whole tool chain, GCC, down to machine code. And it's not going to look exactly like an Objective-C compiler output, obviously, because one is Ruby code and the other one is Objective-C. But whenever you actually create classes, it's using the same methods available in the Objective-C runtime to create a class, to create a Ruby class, as it is to create an Objective-C class, because they're really one type of class. As a matter of fact, every Ruby class is an Objective-C class. Every Objective-C class is a Ruby class. They're the same, which is really fantastic. This was an example application that Laurent actually built called Mustachio that lets you take a picture and it puts a mustache on the face. But it's no longer in the App Store, but he put it up in the App Store. But the main thing to look at here is the size of that application is 0.9 meg. So just to show that this compiled application, which was an app that was released and actually accepted in the App Store that put a mustache on a baby's face, was less than a meg. It's not a very big runtime to be able to support this application. And this is important because applications over, I think, 14 meg still don't allow you to install over 3G. I think it's still the case, and it may depend on the carrier. But there is definitely a limit that says any app over a certain size, you have to install over Wi-Fi or sync, right? You can't install over 3G. So having a small additional library size that RubyMotion brings is really not going to prevent you from building robust applications with this. So let's talk a little bit about the tool chain and how the tool chain actually compiles and produces the applications that we're talking about. First, the entire tool chain is based on rake. You do it from the command line. So when you're running your application, or when you're building your application, you do it with rake. You just type rake. Matter of fact, rake-t to actually get the list of tasks that you can do with your rake command to access the tool chain. From rake, you can produce an an application file that runs in the simulator local within your machine. Or you can say rake device to actually put it on the device. Or you can say rake archive to produce archives for the App Store. So everything is available directly from the command line from rake. You don't have to be inside of Xcode and go into your targets and various things like that and figure out how to do that. You just type rake. As a matter of fact, if you have your device tethered to your Mac and you type rake device, the app pops up on your device. If you just type rake, it pops up on your simulator. It's very nice. And I'll show you some of the specific things you can do while it's running in the simulator, which you literally can't do anywhere else other than this. Another feature that has been implemented recently is full debugging support. So this compiler of Ruby down to native code actually produces a dwarf file, which is a standard file format for debuggers to use when debugging your application like GDB. What that means is you can attach to the simulator running your app, and you can set breakpoints in your Ruby code. And you can get to backtraces and local and instance variables right from within GDB. So this is just an example of GDB running. You start it up. You have the B there in GDB, breakpoint timer controller RB:32. And then it runs until it breaks at timer controller 32. And so you see that come out. And you can, and he checked the backtrace there. That's the BT command, and you actually see the backtrace as it was called through. And if you notice the backtrace, all of those are standard iOS classes, right? That you're calling up through all the way to the point where you're getting into your timer controller, which is your class that you implemented in RubyMotion. So this debugger, I'll show you, tool vendors will be able to use this to actually give you graphical debugging through an IDE. And there's one tool vendor who's actually already doing this, and it's about 2 weeks away from actually being able to release that, which is pretty exciting. Testing. So I want the hands up of the number of people that have developed iOS applications. Okay, how many people have written full tests for your iOS applications? Right. It's extremely hard to write tests, especially functional tests. You might be able to get away with writing unit tests, but even that could be kind of a pain, even in Objective-C. But Ruby is a very strong testing background. I remember all the way back to the first RubyConf that we had in Florida. There were, gosh, probably 5 or 6 of the talks were on testing, even then. And they were said, is this the place that Ruby's really going to take off, is in testing? Because at the time, no one was using it for anything production. So everyone was thinking, well, maybe Ruby could come along and test things. Well, so testing was very important. And HitBy felt it was very important to have testing kind of built into your apps. So when you generate an application with RubyMotion, you get a testing framework that comes with it. It's an RSpec-like language. It's a port of Bacon. And, but it actually integrates with the run loop of UIKit. There's a technology within iOS called UI automation, which lets you drive your iOS applications. But the only way that you can, and so this is kind of like functional testing of a website where you're actually driving the website with functional tests. What UI automation does is actually let you do things like just send gestures to the device and taps and pinch zoom and enter data and things like that. In other words, you can do full functional testing. But if you're going to do this with Objective-C right now, you have to write your tests in JavaScript. Because the only thing that Apple surfaces with UI automation is JavaScript-based testing. With RubyMotion, your testing is in Ruby. So describe the timer view controller, test the timer controller. It has a timer label, and it checks to see that there is a timer with that label. So the view method there looks up a view with that label. And if it doesn't exist, of course, that test fails. So it looks it up, and then it does a series of other things. We'll actually run this test in a couple of minutes when we get into the demonstration. But you can see there that it's getting the label. It's saying the text 2f should be 0. There should be, it should equal 0. And then you tap start, you wait a second, and then you tap stop, and then the text should be 1 because it's basically creating a little counter. And it's checking to make sure that that text is changing because that's what your program does. But it's actually driving the application in your simulator. And you're doing this with Ruby code. So the same language that you're using to write your iOS application, you can write your tests in, which is what we do when we do Rails development or do any other type of Ruby development. We love to actually write our tests in Ruby because Ruby is a very flexible language for doing this type of thing. I mean, being able to do tap, proper wait, tap, getting the different aspects of these things like looking up views. Those are, DSL is an overused word, but Ruby's flexibility in its syntax gives us very, very concise code. And it's very readable code of exactly what this does. So testing is actually built in to every RubyMotion project. And you can do not only unit testing, which you can do, but you can also do functional testing, write specs to do that. RubyMotion doesn't support Xcode, mainly because Xcode kind of sucks, right? And it is really not the best editor in the world. It's just not. Now, so for the last 6 weeks, I've been developing a Windows 8 application for our company. Got it in the App Store. It's on, running on Surface today. But I've forgotten. So I used to use IntelliJ's IDEA, which was an awesome editor for Java back when I was doing Java development. It was just amazing. Once I got into that editor, I was like, this is amazing. In Ruby code, I've never really needed that. But as our projects grow more and more complicated, the IDE becomes actually more missed. Well, having to do a Windows 8 app, which by the way, I did it all in JavaScript, but I was using Visual Studio. Visual Studio, for whatever it costs, which is enormous amounts of money, is an amazingly good IDE. You compare Visual Studio to this, and this is like night and day different, right? Microsoft has hundreds of people working in their tools division, developing tools. That's why corporations buy them. Apple doesn't have that same investment in this team. I can guarantee that the number of people that work in here is dwarfed by the number of people that works on Microsoft Tool Division. And so it's kind of why it's not supported, is because it's just not a really good editor. Instead, the idea is to use the editors you use now. If you use Vim or Emacs, use it. Continue to use that. Sublime, TextMate, whatever you want to use to edit your files. I'm actually going to show a couple of things. So have people here used RubyMine? Right? And I've kind of gone back and forth, right? I use TextMate because David Hansen introduced me to TextMate. But TextMate really was, coming from something that didn't even do syntax highlighting, just had something that did syntax highlighting was fantastic, right? So when I got TextMate, and I was doing Ruby development way before TextMate came out, it was a great step. I go back and forth. I'm trying to figure out which one between TextMate and Sublime that I like, and kind of go back and forth between them. RubyMine was something that I hadn't really used much in my Ruby development, and I've tried, on a couple of Rails projects to do it, and some personal projects I was working on, I kind of did it. But about, I guess it was around 3 weeks ago now, JetBrains came out with RubyMine EAP. And it's the early evaluation program for RubyMine. And it adds the ability to build RubyMotion projects. So you can actually create RubyMotion projects, and I'll show that in a second. But importantly, you can get command completion through the entire iOS API from RubyMotion, from within the editor, including, of course, your own methods that you're defining here. So it gives you command completion with documentation. So you can actually get the commands, complete them out. Because if people know this API, this is an extremely verbose API. So being able to just have this alone is tremendous. And as a very early user of RubyMotion, like very early user of RubyMotion, having to go look up the APIs and then typing them into my TextMate editor and then going and looking up the APIs. And I was doing it, right? Because it was still fun to do, and I was doing it in Ruby. This has helped tremendously just in the last few weeks that I've been using it. It just continues down to be able to do it. So this is coming soon. You might not be able to see this much, but I just got this screenshot sent to me from Laurent. He just got it today. So this is RubyMine integrating with the debugging support. So if you can see what's going on here, I will walk all the way down here and point, because I don't have a pointer. A breakpoint was set at this line of your Ruby code, and the breakpoint fired here, and these are the actual variables which are in the locals of this method right here. So this is real debugger support, and if you notice this call sequence, this is the actual C-based call sequence. So this is the compiled call sequence, but layered in here, you see this Ruby method inside this controller and this Ruby method. So it actually annotates the Ruby methods and the C methods. So you see them mixed in, right? Because you're going to be bouncing back and forth between the Objective-C, or I should say the, the core SDK. You're going to be going between those built-in methods and your own. And this lets you actually see what line of Ruby code that you executed through on the way to the one that you set that breakpoint at, what your locals were, and they're going to be able to expose the full kind of goodness of a debugger with Ruby. And by the way, you can do this while that app is running on your simulator on your device, on your computer. So when you set your breakpoint, you're introspecting what's happening in that simulator in real time. A little bit about the community. So this came out about 6 months ago, May 4th. And there are over 500 projects on GitHub already around RubyMotion. 500. RubyMotion allows you to integrate with something called Cocoapods. And Cocoapods are a way of packaging Objective-C libraries, or actually C and Objective-C libraries, for use on Mac and iOS. So it's both for Mac and iOS, but people are loving it for iOS. And so Cocoapods, and what's really great is Cocoapods itself is written in Ruby. And it's actually a gem. So you say gem install Cocoapods, and then you've got that. But within your rake file, you can actually just include pods. So you require Cocoapods, and then you can include pods. And there are over 600 of them. So these are libraries that have been, when you install a pod, just like when you install a gem on Ruby, it compiles it, right? These pods will come down and build on your machine. So they get downloaded, and they're built on your machine. And then you include the pod in your code, and now you can reference all those classes. The same classes that are in there, or the C functions that are in that pod, you can access from your Ruby code. So now, if you want to use the Facebook library, or name your library that's out there that you want to integrate with, the native library, you can just use it. So we can go back and forth between, do we need to write stuff in C or Objective-C or RubyMotion? But here you don't have to necessarily make that choice. They all actually work really well together. Another really big thing that has happened, and this is the thing that excites me probably the most out of this, is, RubyMotion is amazing in that it is compiling your Ruby code down to native code. This is not another Ruby interpreter. This is a compiler. But Ruby as a language is an amazingly flexible language. I said that earlier. If you look at Rails, and you've looked at all the clones of people that have tried to clone Rails into other languages, right? And you've seen, they've got all kinds of things that people have attempted to do, MVC frameworks that mirror it. Rails is not a DSL. Rails is a series of them that are focused on different areas inside your Rails application. Your migrations, right? You write migrations in Rails, and you look at them. Those migrations is a language inside of there to write migrations. It's the same with your route. Your route file is actually a pure DSL in the sense that now it actually does crazy implicit things with blocks that they never used to do before, but they do now. But your route file is a DSL. Active record is a kind of class-based DSL where you're inheriting from active record base, but you've got your code looks very declarative. And I would say that the main thing about that is that declarative stuff at the top of your file where you're defining your associations and things like that. That's the part of it that is so powerful in Ruby because you can go bounce back and forth. You can use kind of hash syntax. You can use parens where they make sense or not use them. All of that flexibility in Ruby syntax makes it very nice when you're building abstractions. So let's look at a couple of libraries that have come out that are on GitHub that you can build abstractions with. This first one is called Teacup. And Teacup, the top part of this Teacup thing is allowing you to define a style sheet using Ruby code to just define these styles. And then down below, I'm building a UI view controller, and I'm declaring a style sheet that I'm going to use. And then I build a layout called root, and I'm adding a subview, which is a text field that is going to inherit from the style that I defined in my style sheet. This is just an attempt from this library author to build some kind of separation between the, how you lay out your components from adding of the components to the view. Right? Just like in HTML, you want to have the structure of your HTML DOM is separated from the look of your HTML DOM from CSS to HTML, right? That's why you try and do that. You want to separate the two. This is an attempt to kind of do that. It's interesting, right? And there's a lot of these things happening. Matt Eminetti started a project called Bubble Wrap, probably one of the most used, actually, abstraction libraries that's out there right now. It wraps network access. So look at this. HTTP post, so I'm posting a payload data out, and it's just a hash. Now, that hash, by the way, is a NS mutable dictionary. You do open curly brace, key value, that's a hash. It's also an NS mutable dictionary. When you build an array, it's an NS mutable array. Those are types within Objective-C, right? They're in Foundation, and this is built right on top of them. So it's a unified type system. So here he's just posting things, gets a response back. Is the response OK? Then he's parsing it, so he easily parses JSON out and actually gets to the data that's inside of there. But it's not just networks. It's JSON XML, camera, and location support. There's a whole bunch of stuff built into Bubble Wrap. They've looked at the things that are, if you will, the really annoying common things that people do. They want to talk to the network. They want to do JSON-type data access. And a lot of this is just people scratching itches, right? This is why people build these libraries. This one is absolutely fascinating. How many people here have had to build a form on iOS? This is a nightmare. In Objective-C, you build a table view. You build table cells as classes for each one of those rows. Here, you define basically your sections. It's just a hash. So that thing on the left is a hash that generates that form on the right. And all of those things, all those types, at the bottom, you can't really see it, but it just says ForMotion form controller, alloc init with form, and you pass that ForMotion form, and it will actually build that view for you. And you could set data into it and get data out of it as keys and values. Amazingly simple to do that sort of thing. And this is the stuff, to me, that is most exciting. It is the ability of building abstractions on top of it that utilize the power of the language we love to simplify the horror that is underneath it, right? So parse model. So if people have used parse as a service, parse model lets you easily integrate with that service. You can just declare your class post, include the parse model model. You set your fields. Then you can build posts and save them, and it's saving them to the parse.com. Of course, you configure it with your keys and things like that. This is a really fascinating one, motion state machine. It allows you to build a finite state machine for view management. So if you've ever built views that are responding to different kinds of things, your code can get really nasty because things are going through different states and you're changing your views to handle those states. A state machine could be a really nice way of doing that. And if you look at the very bottom of this, it says finite state machine.when awake, state transition in background on notification. So it integrates with the NS notification system to actually let you change your state machine when when things are actually coming from the system. So when the system is telling you that you are about to enter the background, it can actually change your state machine, and maybe that kicks off saving data within your application or whatever you need to do it. So and by the way, this is all built on libdispatch GCD, so it's very efficient and concurrent the way this is implemented. So it's fully concurrent. So I'm going to go through and do a couple of demos real quick. I'm in a mirror mode here. So the first thing I'm going to do is in RubyMine, I'm going to create a new project. And I'm just going to call it RubyConf. And here is where I can actually say it's a RubyMotion application. Say OK. I'm going to pick the SDK. By the way, if you do this, make sure and pick a 19X SDK. It uses this Ruby SDK. It gets all these, by the way, from RVM. It uses this SDK when it's, I'm going to make this, sorry, I'm going to change the font size in this. But it uses the SDK to parse your code and to do syntax highlighting. And you want 1.9, right, not 1.8.7, because 1.8.7 doesn't have Ruby 1.9's hash syntax and things like that. So I'm going to go ahead and build this. Did I do that? There it comes. It's doing its thing, and while it's doing that, I will adjust the size of the monitor, make it get bigger. Might be kind of hard to see here, but what I wanted to show is the structure of this application. The main file that gets generated for you is, let's see if RubyMine lets you, no, you can't zoom this way easily. Anyone know how to quickly zoom in RubyMine? Oh, do that thing? There you go. All right. So the main class is your main entry point into your application is your app delegate. And if you look in here, you're implementing a class that implements application did finish launching with options. This code right here, did finish launching with options, colon that in a method definition. If you look at that, let me zoom out just a little bit so you can see that method declaration. This method is not a valid Ruby method. There is no Ruby method where you actually can set a key and value in the params that you're passing in. Right? That's not what Ruby does. And this was actually added as part of the Ruby syntax for the Mac Ruby project. And this carries over into this, because in Objective-C, the selector, the method you choose, is actually based on the series of concatenated param names. So the actual method name is application colon did finish launching with options colon. That's the selector. That's the method. But in Ruby, there's no easy way to define a method like that, because our methods have very simple little names. So the syntax was added so that you can have this kind of hash syntax. As a matter of fact, it is hash syntax. And it interprets that as your full method declaration. So this allows you to actually implement methods that can, it's easy to call methods that way, but to actually define methods. This is our rake file. So our rake file says the app name is RubyConf. And what's nice here is I can run this app in the simulator. So I'm right here within this tool, and you see there at the bottom of the screen that it's running. Simulator comes up, and the app is there. Now, you don't see anything because it's not doing anything. It didn't create a window or anything like that. But I just wanted to show you that it's very simple to create an application. And by the way, quit out of that. I'm going to show you a little bit more about what you can do. This is your spec that actually starts. If I was to run that spec file, it would fail because right here it says I'm going to get an application. I'm going to make sure the Windows has a size greater than 1 that a window is defined. There isn't one. So by default, your specs fail. Yay, testing. Right, because that's the way we should be doing test-driven development. So this is an example that comes with it. And by the way, up on GitHub, there's RubyMotion samples. And these samples, there are, hold on. There are a whole series of examples out here. I'm going to actually use the timer example. And I'm just going to type first rake-t. And rake-t gives us the list of tasks we have. So these are how you interact with the toolchain. Rake, if I do rake simulator or just rake, it actually runs the app on the simulator. If I do rake, so you see rake config, this shows you all of the different things that you can actually set on your application. This is literally everything that you can do to define parameters on your application. You can set all these in your rake file. By default, these are all the defaults. So it says the default frameworks you're using. So if you're using a different framework, you just add that list, that framework to the list of frameworks that you're supporting. What interface orientations, all these sort of things are available to you to actually override in your rake file. But these are the defaults. So if I just type rake, simulator is going to come up, and this timer is going to come up. Now, there's a couple interesting things that you can do here. The first thing is, I'm going to make it so that I can see if I can both of these at the same time. First, I can do this. Now, what's really cool about that is I said 1 + 1 or 1 + 2 = 3. That looks like IRB, right? That code is being dynamically compiled, injected into the simulator, run, and actually brought back as output to your command line, which is pretty amazing, right? What's even better is, you output self and you've got main. Now watch this little trick. Boom. That's the UI label. Self is a UI label. Self.text. Self.text equals hello. So I'm actually able to adjust what self is by using the command and my pointer over the simulator to highlight the UI widget that I want to introspect, and then I can actually start playing with the attributes of it. If you've ever had to do that where you keep trying to just set the auto resizing mask to figure out how something's supposed to work inside your UI, you can now do this at that level. And this could just get better with IDEs actually doing this, to where the code you're typing in there may be able to kind of in real time be put back into your project or set the debugger. So that's interesting. I'm going to run rake spec on this to run the tests. So this is going to compile the spec. It's going to relaunch the simulator. And the simulator is running. Increases the units. So it's actually clicking the buttons. And it all finished. So if I look at that spec, so this is the spec that actually did that. Now this I know I can increase the size of. And it just ran these series of tests. It accessed the thing. It increased the number. It waited, clicked the buttons. And I was able to write a test that functionally tested my application that I built, which is pretty cool. So all of these samples, and by the way, most of those 500 projects are samples. I mean, there's just a ton of samples that are out there. So that's a quick demo of it. So thank you. I mean, this is actually the conclusion of it. The one thing I will say real quick is, right now, and then through Sunday, there's a 20% discount buying this for RubyConf, and which is good savings if you want to actually try this out. And there currently is no evaluation version of this application. It's like you buy it and you use it. Although, I mean, hit by despair that if you really hate this thing, they'll refund you your money. The main thing is they're a small company that are doing awesomely great things, and they need to be able to support the people who are their paying customers, which is why right now there's no eval version, although there may be one at some point. But right now, the 20% discount is actually pretty significant, especially considering what it does. Also, Matt Eminetti, if you look at Merbist on Twitter, he has tweeted out that he has a discount on the book that is his MacRuby book. That book is actually really good from the standpoint of MacRuby and RubyMotion do a similar thing in that MacRuby is targeted at iOS, at OS 10, and RubyMotion is targeted at iOS. But a lot of the things that you learn from MacRuby you can actually use on RubyMotion, especially when it comes to how it works with the ObjectiveC runtime and things like that. So look for that. And if you search on Twitter for RubyMotion or go to rubymotion.com, you can get this discount today. And with that, I am done. We have time for a couple of questions if people, yes?
Really quick one. I'm curious, why is the mustache app no longer on the app store?
Laurent didn't renew his developer license, and they pulled it off. Yeah, because that's how much he likes Apple. Yes?
What kind of limitations does it put on the Ruby code that we can write? Can we still eval and do stuff like that?
You can't do eval. Eval is the thing you cannot do. But you can still use define method and things like that. So all of the metaprogramming aspect of Ruby is there, just not eval, because you can't actually ship the compiler in the phone. Yeah.
Is it possible to integrate some of that testing with the existing iOS app as a hybrid? Repeat the question.
Yeah, I'm sorry. So the question was, is it possible to integrate with an existing iOS application and build a kind of a hybrid application for testing? So just use this to actually test your application. Not right now, no. I mean, you can use a lot of the code you've written, if you want to actually build something that RubyMotion is kind of on top of. But right now, there's nothing which lets you kind of embed RubyMotion within the application that you've written in ObjectiveC. Right. Yes?
Do you know if the Teacup library and the form library are able to work with each other? Like, are you able to style the forms with the Teacup?
I don't know about that, but yes, you can. So, yes. So the question was, can you debug with the tethered device instead of just a simulator? And the answer is no. You can debug on the simulator, but the actual device prevents you from actually making the kernel calls necessary in order to do that level of debugging. So, just real quick here. Yeah.
Just a quick, are there any plans to support Android in the future?
That is the most requested feature of this. And And there's over 400 million iOS devices that you could start with right now. HitByte knows that it's actually something people really want, and they're taking it very seriously. That's pretty much all I can say on that. Yeah?
What are the advantages of using Apple's toolchain and ObjectiveC versus
Right. So that would be an advantage, right? So theirs is not freaking awesome would be the disadvantage. No, I mean, I actually, I would not write Objective-C applications at this point for iOS, period. Yes?
How does integration with native C library?
How does it work?
Yeah. So Objective-C runtime, but what if I want?
Well, that's what I showed with the OpenGL example. That code that was in that slide is actually calling C code. So all the C constants and all the C functions that are actually available on iOS, which is a lot of them, are callable directly from Ruby.
What if I want to use another library?
You can include it. And that's what the Cocoapods thing is, but you can also include your own frameworks, and you can include them within your app and ship them. You had a question, and then I'll come back here.
When Laurent was on Ruby Rogues, they were talking something about required being...
Not there. Not there.
So if you're writing multi-file...
Yeah. Don't. Just put it all in one file. By the way, you can do that, but I wouldn't recommend it. But it is cool that you can actually have all of your Ruby code in one file, but you obviously don't want to do that for scale. Right now, you have to set the order in which things are compiled if it's order dependent. Like if something requires another thing before it, when you're in your rake file, you actually say, here's the files that I want to build. But they're working on something which actually uses the compiler to actually figure that out as part of the compile step, so you won't have to do that. But right now, just in your rake file, you just say, here's the 10 Ruby files or the 15 Ruby files. And by the way, I've done this in some of my projects. I just say, OK, here's the ones that are really kind of order matter, and then glob the rest of it. And then delete the stuff that's redundant. So it's like a really short little thing to actually get my list of Ruby files to actually build.
So even the gems, dependencies that are coming out of their gem file and that sort of thing?
So if you're, well, I mean, you're not using all your gems that you use in Ruby on this, right? I mean, because some of those things are not.
Oh, but I mean, if you had a gem that was appropriate, would you be able to use it?
There's no require.
Yeah, there's no require. I mean, you can't use things that have require in them. So for example, Cocoapods, there's some things that actually have code where you say require this code, but that's actually being required in the rake task, not being required in the runtime. It literally loads all the Ruby code up and compiles it down. So what you're doing is you're defining what all that Ruby code is that you're defining that space of Ruby code in the order of that. And that's why it was important for very large, as projects get larger, that you're going to want to have something that does automatic dependency resolution. And they're looking at exactly how to do that. And they're working on that. But right now, it's not too hard until apps get tremendously large to maintain that. But a lot of times, it's literally just, I'm going to target these 5 directories and glob them up. Because you can use Ruby to do that in your rake file. We only have time for a couple more questions, but.
Do any of the LLVM static analysis tools work with this?
The LLVM static analysis tools, do they work with this? Because this compile chain, I mean, that you can plug into the process of it actually doing it, like the actual compilation. So I don't think they allow that right now. I mean, because this is, it comes to you as an executable that happens to be built with LLVM. I don't think that they can plug into that process that I know of. Yeah.
Can you use Xcode's instruments?
The what?
The instruments.
Can you use instruments on it? No. So the question was, can you use instruments as part of this application? And the answer right now is no. Yeah. One more, because we have.
Well, because you're a lead developer and you're kind of backward by open source, is there any way you can contribute to this thing or change it?
Well, yeah, so the question was, because we're Ruby's developers and we love open source, is there any way that we can contribute to this? So there's parts of the toolchain that actually are up on GitHub and are open source and do accept pull requests and actually have people actively doing that. But those 500 projects on GitHub are people actively contributing to it. So you don't think as much of the run. It's kind of like, how many times have I contributed to Ruby itself as opposed to building things on top of Ruby? Nowadays, I build things on top of Ruby. I actually did contribute to Ruby a long time ago, but most of the time we're thinking of building things on top. That's where the community is working right now. But it has been, especially in this first 6 months, some work on the lower parts, and those things were open sourced. And they continue to do that, and all the samples are open source and things like that. So, all right, thank you guys very much.